Okay, well, let's see my solutions. Well, I noticed that for the index 0, and then I have the red, and then I have the Asia, so they have this one-to-one relation, right? And in my goal, I want to make the Asia as the key, and then R as the value. So I started a iteration from 0 to 4. So for a iteration from 0 to 4, that is range 5. The reason is, well, 0 is included. That's a start point. And then for the 5, that's the end point, and 5 is excluded. So for a range 5, we really have from 0 to 4. And then for each of the key value pair, and I added that by doing this. So for my dictionary, that's the dictionary name, and then square bracket, I'm putting the key here, which is a continent with the index I, and then for the value, I'm putting a color with the index I. So I'm using the I to get a continent, I'm also using another I to get the value, and then they form a key value pair. Okay, and if you output my dictionary, you're going to have this, and then I'm going to do a 4k in my dictionary, or you can do 4k in my dictionary.keys, and then they are the same thing. And then I'm going to print the k, which is a key, and then I have the Asia, and then it's using the color colon, and then I'm printing the color, which is the value. Okay, and then if you want to check whether we have the Atlantis as a key, well, the right way is we can do a Atlantis in my dictionary. And if you want to check Atlantis in my dictionary as a key first, and then if you want, then you do a my dictionary Atlantis, and if you run this box, nothing happens. The reason is Atlantis in my dictionary is a false. Okay, however, if you want to do this one, you just want to do a print of using the Atlantis as a key to get the value, and then you are going to get an arrow like this. Okay, and you're going to have a key arrow saying we don't have such a key Atlantis. Okay, and then the important question, why do I love dictionaries in Python so much? The answer is simple. We have the O1 time complexity for lookup, insert, update, and deletion. Okay, what is O1? O1 is constant time. Well, why is cool? It's cool because it doesn't matter how big, how fat the dictionary is. Theoretically, in Python, as long as I'm using the Python dictionary for those operations, lookup, insertion, update, and deletion, they are constant time. Okay, and you may ask, what's the magic, or what's the cool things behind this thing? Okay, and then we do want to talk more about what happened in the backend of the dictionary, and that is a hash table. And again, well, in my course, this is not a computer science course, so I'm not gonna ask you to code a hash table by yourself. But I do want to tell you a little bit more, a little bit background information so that you understand why dictionary is so cool. Okay, and for a hash table, in some of the old programming languages, they don't have a hash table built in. So if you want to use a dictionary, a hash table, you have to do that by yourself. And later, in some later programming languages like C++ or Java, they are in standard libraries. And then for the Python, we just have that built in as the dictionary data type. So we don't need to import anything to use a dictionary, right? And for a hash table, another thing we didn't really talk about is that for the keys, they have to be unique. Okay, so if we go back to this one, and then if I want to do a phone book, and then with Jack again, and then if I want to change it to 1, 2, and 3, and I still only have one entry for Jack. However, the value of Jack will be changed to 1, 2, 3. Okay, if I run this and then I run this again, and you can see we still only have one key of Jack. So the rule is, if we run this line of code, if we have the Jack as a key, we update the value to 1, 2, 3. Otherwise, if we don't have such a key jack and then we add the jack and the 1, 2, 3 as a new key value pair, anyhow, we can only have up to one jack as the key in the dictionary. Okay? So let's come back and then we talk about that, and for the hash tables and for the lookup, insertion, deletion, and they are all O1, and compare with a Python list. So Python list, and then if we want to do a lookup, that is a O n in the worst case, so that's linear. And for the insertion, well, that is O1 if it is done as a appending to the end. And then for the deletion, in the worst case, it's also linear time. And what does linear time mean? The linear time means if we have a bigger list in Python, and lookup, insertion, and deletion, they can take longer as the list grows, right? So if you have a really long list and then a lookup, a deletion, it could be very long. However, for a dictionary, we don't have to worry about that. Okay, is that cool? And then we have the constant time of the lookup, insertion, and deletion. Okay, so let's see what really happened behind the scene. Well, say if we have those two lists and then we want to do a lookup, how do we do that? And say we can do Bob in names. So we can do a lookup of Bob. And when we are doing the lookup, and what happened behind the scene is Python will do a sequential search. Sequential search, which means I visit first slot, which is index 0, and then I visit index 1, index 2, index 3, until I got the value Bob. So what's the worst case? The worst case is I don't have such a value Bob in my list, and however, I do have to visit all the values from the beginning to the end. That is the reason that for a lookup, it is the linear in the worst case. Why? Because we have to visit all the members in the list one by one. We don't like that, right? And then the next thing, how about the deletion? Well, the deletion, well, say if you want to delete the index 0, and then when the index 0 is deleted, the index 0 is open. There's no value on the index 0, and that's not right. So all the values, well, we deleted the index 0, and then from the index 1 to index n, all the values have to be shifted up by 1 because the index 0 is deleted. And then this means the deletion, in the worst case, if we are deleting the very beginning, we are deleting on the very beginning, that is also a ON. And we don't like that. That's a linear time, and that time will grow as the size of the list grows. Okay, we don't like that. And then let's move on and talk about the dictionary. And for dictionary, the lookup is linear time. Okay, and then if we do a Bob in phone book, it doesn't matter we have 5 entries in the phone book, or we have 5,000 items in the phone book, and theoretically this lookup should be linear. And then if we want to do a deletion, and then we can go directly to Bob and then delete that, so the deletion is also linear. And you may ask, how did this happen? Well, and probably if you have been to some really old library, and you may see this kind of file cabins, right? So all the files were kept using the first letter of something. Or I just find this, okay? And this is a Hangning file folder, and in our universities, and I still see a lot of people are using this, especially the office administratives, because they are keeping a lot of the files for different person. Say for my department, and probably the office administrative person also doing this right now. Say they want to keep all the files for each of the people in our department in one folder. And then here on this tag, and probably they're going to make a better tag and say that is for the persons with the last name starting with S. Okay, and well, say if we have so many people having the last name starting with S, and then they may do SA to SN in one folder, and then SM to SD in another folder, and they may do that. And well, considering there are many family names starting with S, and probably we are gonna have that. And then let's talk about lookup. When they do the lookup and then say they're looking for a file for me and son, and then how do they do that? And then they're going to look for uh, a S or SO on this tag, and then tada, they go right into this folder and then grab this file, right? So even though doing this is kind of really old school thing to do, and for me, I just keep a bunch of the PDF in my computer, but well, behind the scene of doing such old school thing, well, there is actually a cool algorithm, and this cool algorithm is called hash function. Okay, so let's talk about the hash function. So for the hash function, that is a mapping mechanism that when we have a key, and then using that key, and it will and we use that key, and then the hash function will tell me if I have such a value, where to find that. Say for John Smith, and then it will be pointed to the slot 873. And then how does the John Smith got mapped to 873? That is the power of a hash function. And this hash function is consistent. So if later you want to do another lookup, or you want to change the value using the key of the John Smith, it will always send you to the slot of 873, and then the 873 will have a reference, and then it will send you to the key value pairs. So ideally, well, there should be only one value got mapped to the 873. So when we go to the 873, and then tada, we can find the key value pair using the John Smith. Well, there is a small chance that we may have a collision, and then John Smith and the Sandra D, they both got mapped to 873, and then there is collision. Well, but theoretically, in the Python algorithm, there is a good enough hash function algorithm behind the scene, so the collision will be limited. So just like a office administrative, if he or she wants to find my file, and then they can go into a file cabin with probably dozens of the file folders, and tada, in 1 or 2 seconds, he or she should be able to find the folder for me. And then in Python, when we have a key, we want to use that key to find the value, or we want to check whether we have such a key in the hash table. This can be done really fast. Why? Because we don't have to do a sequential search. Okay, so that's the reason, and that's the power of the Python dictionary. That's a hash table, hash function behind the scene, and that makes the lookup, the insertion, and the deletion all faster. They are all linear time. Okay, so I'm going to pause this video here, and next video we are going to continue to talk about the stats.